Good morning, my dear students. My name is Anjaneya Sharma, working as physics lecturer in one of the reputed institution. Today, we are going to know about important problems related to modern physics. So, based upon this modern physics, in any competitive exam, you will be given mainly 4 to 5 problems, definitely. Okay. So today, our first concept is about photoelectric effect. Photoelectric effect. So what is photoelectric effect? You know, whenever light of suitable wavelength is made to fall on alkali metals like lithium, sodium, potassium, then you know some part of energy is utilized by the metal to extract electrons, okay, and the remaining part of it is useful for kinetic energy, okay. So that is, you know, H nu is equal to, okay, the given energy is utilized to metal in two ways. Certain part for extracting, this you call technically work function, okay, plus kinetic energy. It can also be taken as EV naught. So V naught is called stopping potential, okay. So based on this photoelectric equation, today we are solving problems. So what is your given question? That is, there is one metal plate, okay. So this metal plate is illuminated by light of wavelength given lambda, okay. So in the beginning it is illuminated by lambda wavelength, okay. So this is the metal wavelength lambda. So stopping potential in the first case is 3V naught, okay. So you know, according to Einstein's photoelectric equation, right, H nu is equal to work function plus kinetic energy, that can also be taken as EV naught, right. So in the first case, Hc by lambda also you can write now, nu can be taken as C by lambda, which is equal to work function plus first case, you know, 3V naught, okay. Now on the same metal of wavelength 2 lambda is incident. So I am taking in the second case 2 lambda. Same metal now, so no change in the work function. And you know, stopping potential in the second case is V naught. So nothing but you can say EV naught. Okay. So equation 2, equation 1. So what we require to find under this problem, you want to find threshold wavelength, right? So what is threshold wavelength? You know, minimum wavelength required to produce photoelectric effect. You know, work function is taken as H nu naught now, that can also be taken as Hc by lambda naught, right? Pi equal to Hc by lambda naught. So in order to find lambda naught, you know, you require work function and product of Hc. So thereby you can find lambda naught, right? So first we need to find work function and also this product Hc value, right? So now you divide this equation by 2 because you can equate now solving. It is Hc by 2 lambda. So divide this thing by 2, okay. Okay, so you want to equate these two, so that is why you are equating. Okay, now so you know, whenever you are equating now, Hc by 2 lambda is actually pi plus EV naught. So instead of this, you can write here pi plus EV naught. Okay, take this to other side. Okay, pi minus pi by 2, right? Equal to, EV naught if you take common now, 3 by 2 minus 1. Nothing but 1 by 2 now. So EV naught by 2. Okay, so this is when you further simplify, you get pi by 2 now. So 2 cancel, you get work function value as EV naught. Right? So work function is known to us. No? So pi can be taken as EV naught. So this I am taking now EV naught. Okay. So you want to find now wavelength. No? Threshold wavelength. Okay. So HC value will become 4 EV naught into lambda. Okay, so HC product and you also know work function, that is EV naught. So by knowing these two you can find threshold wavelength. Okay, so threshold wavelength lambda naught. Work function is E pi equal to h nu naught. This can also be taken as hc by lambda naught na? hc by lambda naught. So lambda naught will become hc by pi na? So hc product, you got 4 EV naught lambda, okay, by pi EV naught. EV naught cancelled, you will get 4 lambda. Okay, so remember work function taken as h nu naught. Okay, that is hc by lambda naught. Okay, so for all problems you need to remember only one important point. H nu equal to pi plus EV naught, otherwise kinetic energy. Okay. Now, see, light of wavelength lambda is made to incident on a photoelectric surface in the first case. Okay, corresponding kinetic energy emitted is say Ke maximum. Okay, in the second case it is emitted with lambda by 2 and corresponding kinetic energy is 3 times of initial one they are saying. Okay, so you want to find the work function. Okay, so according to Einstein's photoelectric equation, so light energy given to the metal is always utilized in 2 ways. Certain part extracting electrons and remaining part is kinetic, right? So Ke maxima. So here instead of frequency you have given wavelength na, so that is why it must be converted. hc by lambda, okay, is equal to work function plus Ke maxima. Okay, therefore kinetic maximum in this case becomes hc by lambda minus work function, say equation 1. Now in the second case they are saying kinetic energy is 3 times, so that is why you can take 3 Ke maxima is equal to hc by lambda by 2, because in the second case they said wavelength is lambda by 2, no, minus pi, because light incident over same metal na, so that is why work function does not changes. Okay, now divide second one by first one. So this by this Ke cancel now 3, right? So 3 is equal to, okay, so hc by lambda by 2 means 2hc by lambda, right, minus work function, right, by. Okay, now first one, hc by lambda minus pi na, so take to other side, 3hc by lambda minus 3 pi na, that is equal to 2hc by lambda minus pi. Okay, so you get hc by lambda na, this if you take to other side, or there 3 pi minus pi na, 2 pi, no? So pi becomes hc by 2 lambda. Now about the given problem. So a light of wavelength you have given 500 nanometers. N means nano, you know. No? So wavelength is 500 nanometers. Is incident on a metal, and work function of that metal you have given 2.28 electron volt. You know, electron volt is also one of the unit of energy, right? So you want to find the de Broglie wavelength. Okay, so you know, according to Einstein's photoelectric equation, right? So energy incident, right, hc by lambda. So remember, whenever you want to get energy in EV, you better take this product 12,400, and wavelength must be taken in angstrom, remember. Okay, but over here wavelength is 500 nanometers, so you require one more 10 now for angstrom. You know, 1 angstrom equal to 10 power minus 10, so that is why this I am taking it as 5,000 angstrom. No, 500 nanometers can also be taken as 5,000 angstrom. Okay, so 2 zeros cancelled, you know, 124 by 50, nothing but, you know, 2.48 EV, electron volt. So what is the total energy? 2.48 EV. Out of that, you know, 0.28 EV energy for work function na, this is total, and you know, work function is 2.28. So therefore kinetic energy is remaining na, E minus pi, nothing but, you know, 0.2 EV. So whenever you want to find de Broglie wavelength na, instead of using Planck's constant and all, you can take simply 12.27, okay, by root of this kinetic energy, 0.2 EV. Then you get wavelength in angstrom, remember. So when you simplify na, you get nearly around 28 angstrom. Okay, sorry, 2.8 angstrom. No, 28 angstrom only. So which is equal to, you can take 2.8 into multiple of 10 power minus 9 also. Okay, actually you get around 2.7. Okay. Now about the given problem. They said the incident energy increased by 20%, then the kinetic energy changes from 0.5 EV to 0.8 EV. So in such case you want to know work function of the metal. Okay, so you know, according to Einstein's photoelectric equation, right, E equal to incident energy is equal to work function plus kinetic energy, or you can write kinetic energy is equal to, okay, total energy minus work function, right? So in the first case, you know, kinetic energy is 0.5 EV na, which is equal to incident energy minus work function. But in the second case, they are saying that energy increase by 20%, means 1.2 na total energy. Same metal, so that is why no change in the work function. So in such case, kinetic energy is 0.8 EV. Okay, now, so when you subtract na, cancel, right? So minus 0.3 EV is equal to, you can take 0.2 E minus, right? So minus cancelled, right? So total energy is equal to 1.5 EV. Okay, so you know total energy is 1.5 EV. Okay, you can substitute anywhere, you can find work function. Suppose if you are substituting over here, you know 0.5 EV na equal to 1.5 EV minus work function. So work function will become 1.5 minus 0.5, 1 EV. Okay. So based on this hydrogen spectrum also in the competitive exams you will be given definitely one question. Okay. So now about wavelength. Okay. So wavelength, you know Z square R, you know Rydberg constant na, into 1 by N1 square minus 1 by N2 square. So first about last term of Balmer series, that means you know transition taken to second orbit na, last means infinity, right? So hydrogen spectrum no, so Z value is 1 into Rydberg constant, right? 1 by 2 square minus 1 by infinity square. So right, 1 by lambda 1 is equal to you know Rydberg constant into 1/4, right? So lambda 1 will become 4 by R. Okay. Now in the second case, Lyman series. So you know transition taken from infinity, because they are saying last line na, so infinity to first one, no? So that is why 1 by lambda 2 becomes Rydberg constant into, okay, so 1 by 1 square minus 1 by infinity square. So this 1 by infinity square value is 0 now. So it is nothing but you know lambda 2 is equal to 1 by R. Okay, so you want to find the ratio of wavelengths, right? So lambda 1 by lambda 2, right? So lambda 1 is 4 by R na, by 1 by R. Cancel no, you get 4 times. Okay, so the ratio of wavelengths is 4:1. Now about the given problem. So in this problem, first transition is taken from second to third, right? So you know 1 by wavelength, no, is equal to Rydberg constant into hydrogen like atoms, Z value taken 1 na, into 1 by, so 2, 3, no, so 2 square minus 1 by 3 square. So which is equal to, you can further simplify, you will get 5R by 36, right? Now in the second case, wavelength Rydberg constant into transition taken from 3, 4. Usually you know when electron jumps from higher to lower, then only energy is emitted. No, third, fourth. Equal to 7R by 144. Okay, so when you further simplify lambda 1 by lambda na, this by this, if you are doing, you know, you get 20 by 7 na, or cancelled. So wavelength in this case, you know, 20 by 7 into initial wavelength given, no, lambda. Okay. Now about the given problem. In hydrogen like atom, excitation taken third to second, not orbit. So third excited means N1 taken 4 and you know N2 taken 3. Second excited state na. So energy, you know, hc by lambda, which can also be taken as minus 13.6 of 1 by N1 square minus N2 square. So here 4 na. Okay, so when you simplify, you get 13.6 na of 7 by 144. Now in the second case, you know, second excited to first they are saying, right? So Hc by lambda 2 you can take now, which is equal to minus 13.6 of second to first excited states, right? Equal to 13.6 of 5 by 36. Okay, so when you take the ratio of these two, right? Lambda 1 by lambda 2. No, these are all cancelled. You get 7 by 20 by 7, right? Reverse, no? Okay? So based on diodes, semiconductors also, definitely you will be given 2-3 questions in the competitive exams. Now suppose you have given a question, find the diode which is connected in forward bias. So diode is a valve of cathode and anode. No? So whenever diode is connected in forward bias, so definitely current flows. Reverse bias, current does not flows. No? So when does current flow? Only when there is high potential point connected to low potential point, no? Then current flows. How long current flows? Till both attains to same potential. So you have to find the point where it is connected from high to low. Okay, high potential to low potential. Okay, now you see first case 0 volts minus 2 volts. No, 0 to minus 2. This is high potential, this is low potential. So there is a possibility to send current. No? So that is why this you can say connected in forward bias. Remember, only when diode connected in forward bias, current flows. If it is connected in reverse bias, current does not flow. Because in case of forward bias, the diode is offering very low resistance. So remember, in order to identify the diode which is connected in forward bias, you have to select a point where it is connected from high to low, but not low to high. Now you see second option, minus 4 to minus 3. So you can say minus 3 greater than minus 4 now. So low potential, high potential. So current does not flow. Now next one, minus 2, 2. So this is also low potential, high potential. So current does not flow. Now in this case 3, 5. So this is also low and high. So that is why current does not flow. Now about the given problem, you have given a circuit and they are saying that this cell is offering negligible resistance. Okay, so you want to find current in this circuit. Flow of current anywhere, it is voltage by resistance. Okay, so whenever this type of problems are given, first we have to find about forward and reverse bias of diodes. So remember, whenever diode is connected in forward bias, it will be considered. Otherwise, it will not be considered. You see here, D2 is in reverse bias because positive to N end, negative to P end. Now, so this is taken as P N. So positive turn of the battery to P, negative turn of the battery to N. Then it is said to be connected in forward bias. So you can say only D1 is forward biased. Okay, so voltage 5, total resistance you have to find. Only this we are considering 50 and 20 in series now. So that is why current is equal to 5 by total resistance. Current units ampere. Now ampere is a unit of current. So remember, whenever diode is in reverse, that corresponding resistance and all are not taken. Only one which is connected in forward is only taken because you want to find current now. So current flows only in case of forward bias. Why? Because diode is offering very low resistance. In case of reverse bias, current does not flow because diode is offering very high resistance. Now, based on diodes also, diodes, gates, transistors, you will be given around 2-3 bits from semiconductors. So easiest way of answering is from logic gates. Okay. So in this problem, you have given 2 gates. So whenever gates are given in the circuit, first you must be in a position to identify the gates. Okay. So if you notice, this is one OR gate. Okay, and this one AND gate. So if you know this, it is easy to solve the problem. Okay, OR, addition, and multiplication. No. So AB, no, addition. No. So A plus B. C multiplied with this na is output. A plus B into C gives output. And no, so multiplication operation. Now you have given some cases and you want to get output as 1. Okay, so it is an AND gate. No, so unless the 2 inputs are 1, output cannot be 1. No, but A and B, you can take A1, B0, otherwise B0, A1. But C must be 1, then only there will be output. No, so AND gate. So that is why both the inputs must be 1, then only there is output. So what is condition of AND gate? Unless the 2 inputs are strong, there is no output. So that is why C must be 1. So when you look at the option C0, C0, C0. So C is 1 only in this case. But A1 na enough. 1, 0, 1, 1. So output is also 1. Okay. Now about the given problem. In this problem, you have given 2 logic gates. No? AND gate. Now another AND gate, and you have given a bubble also. Okay. So AND gate works under multiplication operation. Okay. So the output of this AND gate is connected to another AND gate along with C. So first you have to write the output y equal to. So first these two. Now A into B. Okay. So this is one output. And another one is C. AND gate na. So multiply. Bubble. So negation. So A, B into C. Why? Because it is also one AND gate. No? And it is AND gate. So that is why product you are taking. Bubble. That's why negation. So what is your question? When all the 3 inputs are 0 first, next 1. No? So first case we'll take now. When all are 0, 0. 0 into 0 into 0, right? Negation. So 0 into 0, 0 na? So about AND gate. When both the inputs are 0, output is also 0, right? Into 0. Okay. So negation is 1. No? Because in case of AND gate, both the inputs must be strong. Then only there is output. Now you see second case. Y is equal to. Take all are 1. Okay. So when both the inputs are strong, output is also strong now. So 1 into 1. Negation. So 2 inputs are strong, no? Output is also strong. Negation. 0. That means in the first case 1, second case 0. So here when all the inputs are 0. Here, when all the inputs are equated to 1. Okay? Based on transistor also, you will be given one problem. So, in case of transistor, emitter current is always equal to, remember, base current plus collector current. So, this amplification factors alpha and beta, you can identify easily. Remember, whenever the value is less than 1, it is alpha. Okay? Greater than 1, beta. And you know about alpha. Okay? So, alpha is equal to collector current by emitter current. Because emitter is having maximum current, followed by it, next collector, least base. No? So, that is why this value will become less than 1 only now. Now, according to this problem, alpha value is given. No? 0.96 equal to collector current by emitter current known in this problem 7.2 milliamp. Okay? So, collector current will become this 0.96 into 7.2 milliamps now. So, you get around 6.91 milliamps of current, that is collector current. So, in this problem, emitter known, collector known, you can find base now. So, base current is equal to emitter 7.2 milliamp minus 6.91 milliamp equal to 0.29 milliamp. So, very less current is base, maximum emitter. Now, about the given problem. So, 10 power 10 electrons are entered in the emitter region in 10 power minus 6 seconds. So, emitter current equal to Ne by T now. So, number of electrons enter into emitter is 10 power 10. Electron charge 1.6 into 10 power minus 19. In how many seconds? 10 power minus 6 seconds. No? So, plus 10 minus 19. No? So, 1.6 into 10 power minus 9. By 10 power minus 6 na cancelled. No? So, 1.6 into 10 power minus 3. Okay? Is milliamps is the total current. No? Emitter current. Now, 2% of electrons are lost in the base, they are saying. So, current in the base region is 2% now, means 2 by 100 of that 1.6 milliamp. Nothing but you can say 0.02 na into 1.6 milliamp. Therefore, collector current will become emitter minus base na. Emitter minus base. Okay. So, you get 0.98 na into 1.6 milliamps. So, you want to find amplification factor beta. So, that is beta is always greater than 1 na. So, collector by base. Okay. So, collector 0.98 na into 1.6 milliamp by base 0.02 na into 1.6 milliamp. Okay. So, these two are cancelled. Now, points cancelled. So, 49. Amplification factor is 49. Okay. Now, about nuclear physics. So, based on this radius of nucleus also, you will be given some problems. Okay. So, radius of nucleus is equal to R naught into a power 1 by 3, where R naught value is 1.2 Fermi into a power 1 by 3, where A, mass number, and remember 1 Fermi equal to 10 power minus 15 meter. All nuclear distances are measured in Fermi. Okay, so ratio of radii, it is constant now. So A1 power 1 by 3 by A2 power 1 by 3. So in this problem, radius of aluminium you have given RAL. Okay. By second one you want to find, that is about tellurium. Okay, equal to A1, mass number of first one 27 na, by second one 125 power 1 by 3. Okay, so 27 you can write 3Q, 125 you can write 5Q, right? So 3 by 5 whole power 3 into 1 by 3. Cancel now. So R2 is equal to 5 by 3 times of radius of aluminium. Now about the given problem, there is one radioactive sample. Okay, its half-life you have given 12.5 hour. Okay, and initial mass of it is given as 256 gram. Okay, so you want to find the time taken by it to get only 1 gram. So 256 grams of a radioactive sample, so disintegrated, so that only 1 gram is left. Okay, so the time taken by it you want to find. So in this type of problems, n by n naught, okay, is equal to 1 by 2 power t by t. Okay, so n always denotes about left mass. This is initial mass. Okay, this one half-life, and this is the allotted time, we can say. Okay, so here 256 is initial and final is 1, right? So you can take directly 1 by 256. Okay, initial 256, left 1 that is equal to 1 by 2 power allotted time you want to find. No, half-life given as 12.5 hour. Okay, so this 1 by 256 you can also write 1 by 2 power 8 is equal to 1 by 2 power t by 12.5, right? So whenever bases are equated, powers are also equated now. So 8 is equal to t by 12.5 hours. No, so time taken is 100 hours. That means 256 grams of a radioactive sample takes 100 hours to complete disintegration, so as to left only 1 gram. Now about decay model. So based on alpha decay, beta decay or gamma decay, you will be given one question in the competitive exams. In this problem, there is one element, okay, mass number m, atomic number n. So this emitted alpha particle and 2 negative beta decays. So after the emitting these particles, you want to know the nucleus. Remember, whenever alpha decay takes place, so in such cases, remember, number wise 2 subtracted, okay, mass wise 4 subtracted, because you know alpha particle means double positive helium ions. So that is why mass wise 4, number wise 2. Okay, some other element, say y. Followed by it, they are saying 2 beta decays na. So whenever a beta decay takes place now, then remember mass wise no change, only number wise one added or subtracted, but this is negative beta decay, so that is why number wise one added. Okay, 2 negative beta decays no, that is why 2 times 1 added. So thereby you know you get some other element, but mass wise no change na, m minus 4 only, number wise cancelled, n left. Okay, so this. Now about the given problem. So helium element, you know, it is formed by 2 deuterons, no? So the binding energy of this helium given as 28 MeV. So you know each deuteron having energy 2.2 MeV. No? So energy released is equal to binding energy of helium given as 28 MeV na, minus, you know, 2 deuterons combined together forms helium. No? So 2 times of binding energy of each deuteron, 2.2 MeV na. So you get 28 MeV minus 4.4 MeV. Okay? So you know it is 23.6 MeV. So the energy released in this process is 23.6 MeV. Now about the given problem. There are 2 radioactive materials X1 and X2 having equal number of nucleons. First decay constant is 5 lambda, next one is lambda. They said after a certain time the ratio of disintegration given as 1 by E. That time you want to find. So you know according to law of radioactivity, N equal to N0 into E power minus lambda T. Okay. Now about first one, N1 is equal to, okay, E power minus 5 lambda T, okay, into N0. Second one, N2. You know decay constant is lambda na, so E power minus lambda T into N0. You have given that both are having same number of nucleons. Okay, now ratio N1 by N2. Okay, so that is equal to, you know, E power 5 lambda T na by E power minus lambda T, which is given as 1 by E. No? So this can be taken as E power minus 4 lambda T na, which is equal to E power minus 1. Okay, so whenever bases are equated, powers are also equated. Now, so time taken to get ratio as 1 by E is equal to 1 by 4 lambda. Thank you for watching this video. So I made a number of videos which are very much helpful for all competitive exams like NEET, MAINS, EAMCET. So if you want anyone among it, I have given in the description box. Okay, you can watch. Links are given in the description box. You can watch at any time. Thank you.